Okay, question 20. Sketch the graph of sine to minus 1 of x, so values between minus 1 and 1. Now, the inverse function of sine, right, will always be between minus 1 and 1. They're not going to change that because that's only where it exists, right? You can think of it like this way. If you think about the sine x graph, right, we only need to focus on the first bit of it. But if we think about what's going on really between 90 and minus 90. Okay, so here, right, that's 90 degrees, isn't it? There, of course 90 degrees we'd write as pi over 2, right, in terms of radians, because radians does help in this particular topic, because we're going to differentiate now in a minute and so on, so we need to have it in radians, and minus pi over 2 here, and 90 degrees there, minus 90. Of course, now we know this is 1 here, and we know this is minus 1 down here. Okay, so when it comes to the inverse function, of course, if you remember, you're reflecting the line y equals x, okay, and that's what we're going to kind of do here, reflecting the line y equals x, but it's restricted. Okay, you can't have all the graph of sine x, because you end up having two solutions, a many to one situation, which is no good. You need to restrict it, so it's 1 to 1. So we're going to restrict it, so it's between minus pi over 2 and pi over 2. So we can ignore this here, ignore this. And if I drew the line y equals x, well, y equals x would be something like this, okay? Roughly something like this. Okay, it's quite hard to draw it, because I haven't done this accurately. So that's the line y equals x there. Okay, so when x is 1, when y is 1, x will be 1 as well. Now if I was to reflect this, you get something like this. So reflect this here in the mirror line, so you end up going similar to this, and then because they cross there, so we're going up like that, and then reflect that there and go the other side of the line. So it goes something like that. Now it's not perfect, right? My drawing isn't particularly good, but what I want you to notice is there's a positive gradient. Okay, it's a positive gradient all the way there for sine to the minus 1 of x. Okay, so it's a pretty poor drawing. I wouldn't want you to draw it like that in the exam, but I wanted you to get an idea of where it comes from. The inverse sine graph is the positive gradient, because in the formula booklet the derivative is given there, 1 over square root 1 plus x squared. That's positive, isn't it? So you've got to remember that as positive gradient. And when it comes to drawing it, okay, the way I always do it is like this, right? So I always put the values in minus 1 to 1, okay, minus 1 there, 1 here, and I get my calculator and I type in sine to the minus 1 of minus 1, okay, and I get out minus pi over 2, okay, so I end up down here minus pi over 2. There's a point there. If you put 0 in, it literally comes out as 0, and if you put then positive 1, the other end of the range, it comes out as pi over 2. Okay, so it's up here somewhere. Okay, so there's your graph. It looks like a straight line, but what actually happens is it goes a little bit like this. Okay, right. So that's the idea. That's what basically you get with sine to the minus 1 of x. Right. So if you put those values in your calculator, you've got an idea then what it looks like, and the key to it is realizing it's positive gradient. Okay, right. Part B then, it says by first writing y equals sine to the minus 1 of x as x equals sine y, because if you think about it, if you take that inverse sine over, you get sine y, won't you? So x equals sine y. Okay, so take that over, so you get sine y equals x, so you get this here. Now if we differentiate it with respect to x, that becomes 1, that becomes cos y, sine becomes cos, but of course you've got to plonk a dy dx on the end of it, because it's in terms of y there, and then so dy dx will equal 1 over cos y, okay, and then what you do is a little bit of rearrangement then, because we know sine squared y plus cos squared y equals 1, cos squared y then will be 1 minus sine squared y, and then cos y will equal plus or minus square root 1 minus sine squared y, so you just chuck that in there, 1 over, okay, cos y becomes plus or minus square root 1 minus sine squared y, and then you need to make some sort of statement. You need to say, look, take positive gradient, take positive root, sorry, because dy dx must be positive, okay, must be greater than 0, as we've just justified with our graph. So therefore dy dx will equal 1 over the positive root 1 minus, now sine squared y, well we know sine y is x, so sine squared y will be x squared, and you get the result from the formula booklet.